Okay, let's take a look at review problem 4.13. X and Y are Poisson random variables that are independent with different parameters lambda and mu. We want to find the conditional distribution of x given that x plus y is equal to n. Okay, so to find the conditional distribution, that means we need to find the probability that x is equal to a certain value of k given that the sum of x and y is known to be equal to n. Okay, now x and y are Poisson, which means that they must take values that are greater than or equal to 0. So the values of k must lie between 0 and n. That's the most it can be, and k is not permitted to be negative. So that's equal to the probability that x is equal to k and x plus y is equal to n, divided by the probability that x plus y is equal to n. I know x is Poisson with parameter lambda, and I know that y is Poisson with parameter mu. Because these are independent, I know that x plus y is also Poisson, and the parameter will be lambda plus mu. Alright, now I'd like to split this up, and the way that I'll split it up is by writing that as the chance that x equals k and also y is equal to n minus k. So therefore the sum x plus y is equal to n, divided by the probability that x plus y is equal to n. Okay, so let's figure this out. So that splits up probability that x equals k times the probability that y is equal to n minus k, divided by the probability that x plus y is equal to n. So using the Poisson distribution, this is e to the minus lambda times lambda to the k over k factorial. This one is e to the minus mu times mu to the n minus k over n minus k factorial. And on the bottom we have e to the minus lambda plus mu times lambda plus mu to the n over n factorial. Now, can I do better than this? Well, clearly the exponential terms cancel. And if I rewrite this, I get n factorial over k factorial, n minus k factorial. Then I have lambda to the k, mu to the n minus k, over lambda plus mu to the n. Now this looks familiar. That's a binomial coefficient. So maybe this is a binomial distribution, and choose k. Let me rewrite this as lambda to the k, mu to the n minus k, over lambda plus mu to the k, lambda plus mu to the n minus k. So this is still lambda plus mu to the n if I add up the exponents. Then this becomes, and choose k, lambda over lambda plus mu to the k times mu over lambda plus mu to the n minus k. And notice that these two things inside the parentheses add up to 1. If I add up the things inside the parentheses, I get lambda plus mu over lambda plus mu, which is 1. So this follows a binomial distribution. So the conditional distribution of x given that x plus y equals n is binomial with n trials, and the probability of success will be lambda over lambda plus mu. So that's the conditional distribution of x given the sum is equal to n.